Hello friend, I'm Samadhi back to new video regarding IS456-2000. So in this video, we'll talk about the from clause number 28, that is the corbel, that is concrete corbel. Okay, so before this, we'll talk about the 27th number of clauses, and in case you didn't see it, then definitely go to the I button. Otherwise, go to the playlist section and definitely will find the IS code playlist, so you can see it. So without further delay, let's get started. So what is basically concrete corbel? A corbel is short cantilever projection, so that is generally cantilever. Okay, so short cantilever projection. If this is your wall and if this is your cantilever projection, okay, so this is your known as corbel. Okay, and we'll make corbel by using concrete. That is why the 28 number clause is named as concrete corbel. In a distance between the line of the reaction to supported load and the root of the corbel is less than d, where d is your effective depth of the root of the corbel. The depth at the outer edge of the contact area of the supported load is not less than one half of the depth at the root of the corbel. Design. Simplifying some assumptions, the concrete and reinforcement may be assumed to act as element of simple strut and tie system with the following guidance. The magnitude of the resistance provided to the horizontal force should not be less than one half of the design vertical load of the column. That means horizontal load is not less than not less than half of the vertical force. Okay. Compatibility of strain between the strut and the tie at the corbel root should be ensured. It should be noted that horizontal link requirement describe satisfactory service and performance. Reinforcement anchorage. In case the anchorage is needed at the front face of the corbel, the reinforcement should be anchored. That means this is your front face should be anchored. Welding to traverse bar of equal strength. Welding of traverse bar equal strength. In case of bearing area of the load should stop short of face. Bending or buck the bar from loop. Now we talk about your shear reinforcement. The shear reinforcement should be provided in the form of horizontal link distributed in the upper two-thirds of the effective depth. Suppose this is your effective depth. Upper two-thirds effective depth, we should provide what? Shear reinforcement. Okay. These reinforcements should be not less than one half of the area of main reinforcement, main tension reinforcement. So these shear reinforcement area not less than not less than half of the main tension reinforcement. Okay, so what should be the side reinforcement provision, and this is your area provision. Okay, resistance to applied horizontal force. Additional reinforcement concrete to be supported member should be provided transit. Now we talk about the deep beams. from deep beams, you may find some question from the uh, to the in the government exam. So first they ask, what is your deep beam? A beam shall be deemed to be deep beam when overall span to overall depth is less than 2 for simply supported beam and 2.5 for a continuous beam. So this is very important. Then call lever arm. Lever arm means the distance for calculating moment, that is known as Z. For simply supported beam, the Z value is zero point 0.2 L plus 2D when L by D is 1 to 2. If less than 1, in that case Z equal to 0.6 L. For continuous beam, Z equal to zero point 0.2 L 1.5 D when L less than 1 less than L by D less than 2.5. For simply supported 2, for continuous beam it is 2.5. Z equal to 0.5 when L by D is less than 1. What is the protection? Okay, fine. Reinforcement. So reinforcement two type. One is positive reinforcement, other is negative reinforcement. First we will talk about the positive reinforcement. The tensile reinforcement equal to resist positive bending moment in span of a deep beam shall extend without curtailment. So no need of curtailment. Be embedded the face of the each support at the face of it shall have a development length not less than 0.8 L, where L is the development length for the design stress in reinforcement, and be placed within a zone depth equal to 0.25 D to 0.5 L adjacent to the tension face of the beam. So this is the zone of depth. Now talk about the negative reinforcement. Termination of reinforcement. For tensile reinforcement require resist negative bending moment over a support of a deep beam, and that is distance of 0.5 D. Distribution. When the ratio of the clear span overall depth is range of 1.0 to 2.5, tensile reinforcement over a support of a deep beam shall be placed in two zones comprising a zone of depth 0.2D and zone of 0.3D. Okay. For 0.2D, the formula is this, and for 0.3D, the side of mid depth, which shall contain remain the tension. For span of depth ratio less than unity, the steel shall be evenly disturbed over a depth 0.8 D measured from the tension face. Now we'll talk about the vertical reinforcement. If force are applied to a deep beam such a way the hanging action required bar suspension stirrup shall be provided to carry all the force. The side reinforcement shall comply the requirement of minimum reinforcement of wall. So when we'll read 32.4, we'll talk about the side reinforcement. Okay. So this is very simple, basic uh, video regarding corbel as well as deep beam. Okay. In next video, we'll talk about rib, hollow block, and flat slab. Okay. So here I will end this video. In next video, I'll talk about this. In case if you have any kind of doubt regarding IS code, then without feel any kind of hesitation, do comment in comment section. Till then, bye bye, take care, and thank you for watching this video.